Hi there. Thank you for clicking on this video. This video lesson is going to take us through an introduction to quadratics. So before we launch into how can we solve them and what's modeled by them, let's just answer the question, what are they? Please give this video a quick thumbs up if you find it helpful, comment and subscribe to engage, and check out the other videos and playlists on the channel. I'll try to link some of those in the description or at the end of this video so you can explore what else we have on the channel. First off, what is a quadratic? Like I said, before we get into how do we solve them and what do they model, it would be really good to have our feet firmly planted in what are they. So if you are studying Algebra 1 and you're going through stuff for the first time, this might be the first time you've even seen the word quadratic, or maybe you've encountered it a little bit in class and you're checking out this video to see if you can learn some more about just what are they. So quadratics are very easy to conceptualize, but they're very hard to define. In other words, it's hard to define it without introducing other vocabulary words. And so I could come up with tons of examples of quadratics. I think most of my students, if I said just make up a quadratic, they could do it. And then when you start to try to define what it is, we start getting tangled up in the vocabulary. So after thinking about it, I thought about defining it this way. If you've recently been studying lines, so typically you would study everything you needed to know about lines before you study quadratics. Quadratics would be like the next thing. Then this might work as a definition. Okay, so you've been studying lines. Take a linear equation in slope-intercept form. So that is the y equals mx plus b, okay? And then add an x squared term to the front of it, okay? So if you had, say, y equals 2x minus 4, you might just slap an x squared right onto the front of it, and that would make it a quadratic. So it is no longer linear, it is quadratic. So maybe something like this, it might be like x squared plus mx plus b. Okay, or what's more common is we don't use the m and the b anymore. We use the letters A, B, C going straight down. So I put just an x squared out in front, but if you look over to the left, like I could have done, say, a 3x squared. And so typically what we do is we use an A to represent the number in front of the x squared, or the coefficient of the x squared. We use a B to represent the coefficient of the x, and we use a C to represent the constant, just so they're going in alphabetical order. Okay, so like literally just A, B, C. And we kind of saw that when we were looking at standard form for an equation for a line, where we had like the ax plus by equals c. And so we have a little bit of familiarity with just like pick an a, b, and a c, like those are numerical values. And we don't use the mx plus b. Some graphing calculators, instead of using y equals mx plus b, just like a heads up, when you go to work in the calculator, it'll be ax plus b. And that's to retain the idea that we go in alphabetical order. So they use an A to represent the slope. So just a little heads up that you might see that. But that's essentially what a quadratic is. And so you don't want to be seeing other stuff in there, because sometimes people will say, well, it's an expression with an x squared. But if you saw an x to the third, that's not a quadratic anymore, even if you see an x squared. And there's a lot of other things that could happen. Like, what if you see an x squared and then you see an exponent like x to the negative first or something, and which we don't want to get into what that is. So I think for practical purposes, picture a line in slope-intercept form and then adding some kind of term to that would include the x squared. So the technical definition is something like a polynomial of degree 2 is what the technical definition is. The degree 2 being a reference to the exponent of 2. So if we look at ax squared plus bx plus c, the degree 2 part has to do with the exponent being 2. But the word polynomial, now we're opening this big can of worms as to what is a polynomial and what are the rules for putting a polynomial together. So the good news for you is that a line is a polynomial. A line is a polynomial of degree 1 if you think of your mx plus b. The exponent on the x there would be 1, and so a line is a polynomial of degree 1. A quadratic is a polynomial of degree 2, and we will just leave the definition of polynomial for some future lesson way out in the future, okay? So a key trait with your quadratics is to simply look for the x squared. So we actually say that a lot in math classes. If your teacher says, how do I know this is a quadratic? Probably the answer that your teacher's looking for is because of the x squared. That's what they're looking for you to say. But not everything that has an x squared is a quadratic, okay? Just heads up. So here are some examples of quadratics. I mentioned earlier that this is fairly easy to generate examples of and then a little tricky to define. So let's look at some examples. This would be a quadratic equation that you could solve for x and figure out the solution. Remember, the solution would be the value of the variable that would make it true. So you'd be looking for what could I plug in for x? This one might not have a real solution, but what I want you to notice about it is the x squared, the x, and then the constant. So something x squared plus or minus something with the x plus or minus something with a constant, and that's all equal to 0. This one's a little weirder, but again, you want to notice the x squared there, and then it's equal to 4. The fact that you don't see an x, what that means, I'll kind of hop over to the right here, is that you might have 3x squared plus 0x is equal to 4. And so you don't necessarily see the x there. But again, that key part, remember I said if your teacher is asking you, how do I know this is a quadratic, what they're looking for is the x squared part. Okay, that's the part that they're looking for. This one is missing the constant, so it's negative 4x squared minus x, but you could think of that as negative 4x squared minus x plus 0 equals 0. So in this case, the constant might be a 0, so that would be a quadratic. Now, these ones are ones that you wouldn't necessarily solve because they're not equal to a numerical value. They're equal to y instead. So this might be something that you could graph. You would be looking for the pairs of the x's and y's that would make this true. So this would be y equals 3x squared plus x. And again, if you're like, ooh, but what about that the number? Well, it could be a plus 0, okay, at the end there. Y equals negative 1/2 x squared minus 2x plus 1. Now, what I was going for here was the idea that you could multiply by negatives, you could multiply by fractions, that you really don't have restrictions on what numbers you might be multiplying by. So you can see we have positive integers, negative integers, and like wanted to throw a fraction in there. Just to be really clear, this one is a 1 up at the top there. That's 1x squared. So like really anything goes as long as it's a real number. We don't want to get into that right now, but you know, for your coefficients. And this one is missing the x. Okay, and so you might say, ooh, but like, what about that? Like, that doesn't look like it fits it, but it could be 4x squared plus 0x plus 3. And now you can see that, like, yes, it actually does have all of the parts that we need. So take a moment, pause the video, even look at all those examples and just try to get a feel for what quadratics look like so that when you're staring at an equation, you know this is the type of equation that I am dealing with. All right, so what forms can a quadratic take? Just as the lines can be in slope, intercept, point, slope, or standard form, quadratics can be arranged in different forms. So if you've done a study of lines, you know that you could write a line in slope intercept form, you could do point slope form, and you could write the equation in standard form. And we've covered all of those forms on this channel. So if you're need a refresher, go into the algebra playlist, or I even have a lines playlist. I did do some shuffling of those videos. So go into like the lines playlist and you should be able to find the video on whatever form that you would like to review. So just like you can do that with lines, you can also do this with quadratics. Now in Algebra 1, we typically stick with what's called standard form, which is that y equals ax squared plus bx plus c, where a, b, and c are real numbers. Now this I have to put in here, okay? I can't just say they're numbers. I do have to say they're real numbers. And if you're in Algebra 1, you're probably wondering, what do you mean? Like what, like a fake number? No, it's not. They're not called fake numbers, but there are some numbers that we would say are not real. So, so this is the form we typically stick with, and I had in my original notes to put the other forms out there, and then I thought, no, like in Algebra 1, you don't really do anything with the other forms, so I don't want to muddy the waters with them. However, if you are looking for information on the other forms, I will at some point have some videos up on those other forms, so you could go find those probably in the Algebra 2 playlist. Keep in mind that A, B, and C can all equal 1, and that B and C might be equal to 0. So if you saw x squared plus x plus 1, that would be 1x squared plus 1x. So if you don't see the coefficient would be a 1. If you saw like x squared minus x plus 1, remember that this would be a coefficient of -1. And B and C can both be 0. So if you just saw the x squared and nothing else, okay, so you didn't see anything else, it could mean that it was x squared plus 0x plus 0, or you might see x squared plus 3, which would be from x squared plus 0x plus 3, or, and I think we looked at this before, you could see x squared minus 2x, and that would come from x squared minus 2x plus 0. So the B and the C values might be 0. The A value cannot be a 0, because if you put a 0 out in front of the x squared, 0 times x squared would be just 0, and you would actually be left with something linear. So you would be left with the x plus 1. And remember that for it to be a quadratic, you do have to see the x squared. So A cannot be 0, but B and C might both be 0. So this is just an exercise in identifying A, B, and C in these quadratics. So if you'd like to pause the video here and just try to figure out what's my A, B, and C value, go for it. If you just want to keep the video on, I'll walk through it. First one is the most straightforward one. So remember, ax squared plus bx plus c is equal to 0. And if I look at this first one, it's 2x squared minus 3x plus 5. So in the first one, a is equal to 2, b is equal to -3, and c is equal to 5. And that's about as straightforward as it can get when you see all of the coefficients and they line up perfectly. So ax squared plus bx plus c, you got the 2, the -3, and the 5. Most common mistake is to leave the negative off of the x term there. Second one is 1/2 x squared plus 3x equals 0. And for this one, we would want to note that the a value is 1/2, the b value is 3, and the c value is 0. So if you don't see the plus a constant, like it would be 0. So this would be 1/2, 3, and 0. Next one, we've got x squared minus 5 is equal to 0. So in this one, remember I said you might have a 1 in front, and I've had so many students over the years tell me, oh, a value is x squared. No, like a, b, and c are numbers. They're always numbers. So you never tell me that a or b like has an x in it, okay? No, it's the number out in front. So in this one, the a value is 1. The b we don't see, which means it must be 0x, because 0 times x would be 0 and it would drop out. So the b value is 0 and the c value is -5. Make sure that you do know that that is a -5 and not a +5. Next one, we've got x squared plus x, and then we have equals 4, and that is problematic, okay? So if you're identifying A, B, and C, you need to make sure you have it equal to 0, otherwise we will have an issue. So the way we resolve that is we're going to subtract the 4 from both sides, which will give us ax squared plus x minus 4 equals 0. And now we can see our values. We have 1x squared plus 1x minus 4. So A is 1, B is 1, and C is -4. If you don't put it in that form where you have the 0 on one side, then what you'll end up having is C is equal to +4 instead of -4. And that will cause all of your everything to just be wrong. So we want to make sure that we have the correct sign on that. Next one is 2x squared minus oh, nope. I want to make sure I get this right. I wouldn't think that like I just wrote this problem, but okay. So this next one is 2x minus x squared plus 3 equals 0. And this one is playing off the fact that they're given to you out of order. So you've got your bx first and then your ax squared. So if I were looking at this, I would know, because I've done this for a long time, that the a value is what's in front of the x squared. And so I would look at that and say, okay, that is -1. The b value is always in front of the x, and so that is a 2, and then the c was okay. What I would recommend most of my students do, though, is that they actually change the order of it. So we would rearrange this. Remember that this is plus a negative, okay? So subtraction is always plus a negative. And so when I go to switch the order, the negative on the x squared has to come with it. And now you might be able to see a little bit better. Okay, that's -1x squared plus 2x plus 3. So if you can do it without rearranging it, knock yourself out. Have fun with that. But when you get to some of the problems that are coming up, you're going to have to rearrange it anyway to be able to see where everything is. And so you might want to just get in the habit of doing that. Last one is -3x squared equals 2x minus 6. And remember what I said about it needing to be equal to 0. So you actually have 2 options here. So you could get the 2x and the -6 over on the left-hand side. So we could do that by subtracting 2x from both sides and then adding 6 to both sides. And so the left-hand side would now be -3x squared minus 2x plus 6. And then on the right, 2x minus 2x is 0, and -6 plus 6 is 0, giving me the 0. So my values of A, B, and C could be -3 for A, -2 for B, and 6 for C. And that would be totally fine. Or you actually could do this, where you added the 3x squared to both sides. And so -3x squared plus 3x squared is 0. And then you would have 3x squared plus 2x minus 6. And if you did that, you would have 3, 2, and -6. So, and actually both of those would work for what you would intend to do. Now I prefer to have the a value be positive. Okay, I would just prefer that, but for a lot of, like, either one of those answers would be correct. You might be wondering that. I'm like, I don't know why either one of them should be correct. For now, you just have to trust me, and we can take a look at the why in a future video. So let's quickly explore what the graph looks like on this. So we're going to create a table, and what we're going to do is what's called the parent function or parent equation here. We're going to do the simplest equation that we can find that's a quadratic. And I'm going to go ahead and pick some values of x to go ahead and plug in. and we're going to take a peek at what this graph might look like. It's going to be too bad to do. So the graph is simply to square your x value. So if x is -4, we would do -4 squared. Well, -4 times -4 is +16. And so -4, I'm going to come up to +16. So that point is on the graph. Next one, y would be equal to -3 squared. Well, -3 times -3 is +9, which puts me right there. I don't know why I changed my color there. Next one, y would be equal to -2 squared. -2 times -2 is +4. And you'll notice that this is not actually a straight line, that it got a lot less steep. Like that drop, rise over run, is a lot steeper than this drop right here. You definitely don't have as much rise going on. For the next one, y is equal to -1 squared. Well, -1 times -1 is +1. And now you can really see it. Okay, we definitely don't have as much rise. Next one is 0. Well, 0 times 0 is 0, so that's the point 0, 0. And then what you want to notice is that you're going to have some symmetry here. So 1 squared is 1, so it actually like turns around and starts going in the other direction. 2 squared is 4. 3 squared is 9, and 4 squared is 16. 3 squared and 4 squared. And we know, of course, that we could pick lots of points in between those points. And so what I'm going to do is try to connect this with the smoothest curve that I can. And that's just a mediocre job. But that's generally what it looks like. And I think it's really important for us to go back and remember that no matter what the equation is, we can plug in some points and like see, like get an idea of what the graph should look like. So that's what the graph of a quadratic should look like. And just notice a few things. Note the symmetry of the graph and the point where it turns around. So those are just like things that you want to notice, that, yeah, there is some symmetry to it, and there is a point where it turns around. So it's going down and then it's going up. These become important as you study more about this equation type. So in upcoming lessons, we're going to go into depth about how you can solve these types of equations, and we'll look at what real life things are modeled by quadratics. So that's pretty much what you can expect from this point on in our study of quadratics. Don't forget to like and subscribe for more math content. Drop a comment or question below, and check out some of the other content on the channel. I'll link you over here to our Desmos playlist, where you can check out how to graph quadratics on Desmos, and I'll see you in the next video.